Okay, so what I want to do now is answer a few of the questions that you guys posted for Chapter 13. And what I've done is put the questions on the top of some of the slides that they go with to kind of help focus what we need to talk about on those. So this first question says, with all the benefits of cooperative breeding, why is this not something we see more often? So even though you see over here a list of benefits that cooperative breeding definitely provides to species that do it, you also can see over here that there's actually a pretty high list of costs as well. So in all of these, essentially, it's not going to evolve unless the benefits outweigh the costs. So if you have a species that's prone to parasitism, one of the big things would be if there's limited resources and there's a lot of competition. So working in a group is great, but if all of a sudden now you're competing with other individuals in the group for food, then perhaps cooperative breeding is not beneficial. So it really is going to depend on that ratio of cost to benefits. So different ecological circumstances for different species will tip that scale in different directions depending on, again, what those circumstances are. The second question here says, are there examples of animals regularly switching groups for benefits to avoid costs? So basically you're in one group and you're getting the benefits and then you just kind of jump over to another group. I think part of the problem that you would have with animals doing that is that, remember we talked about how when you have some sort of reciprocity in systems where you're helping one another, one of the stipulations that keeps something like that going is the idea that animals that do not reciprocate will be punished. So animals that take all the benefits and don't get the costs, there has to be the evolution of some sort of mechanism by which those individuals are not allowed to continue to do that. So I think what would happen is if you had individuals switching groups to avoid those costs, that you'd probably also see the evolution of a little bit more discrimination as to who's allowed to join a group, because those might be individuals who are coming in sort of short term, taking advantage of the situation and then leaving. So it could be that there's definitely penalty for that. Are there some examples of that happening? I'm not really sure. I'd be surprised to find out that there's not something out there where certain animals have been able to sort of overcome that little stipulation and been able to jump from group to group. But I don't know if it's something that would persist long term in an evolutionary framework, because again, evolutionarily that should be something that is essentially filtered out of the system. This question talks about temporal variability hypothesis that supports cooperative breeding. There's a couple of reasons why we would see less cooperation when you have more promiscuity, but the majority of that is probably the fact that individuals, when there's more promiscuity and less monogamy, what you're finding is individuals that are in a cooperative breeding unit, let's say extended families if you will, are less likely to be related to one another, for one thing. So because they're not as related, it's less likely that you're going to get some of this cooperative breeding to evolve, because you would have less kin selection working. So the benefits of being cooperative definitely intensify under monogamy, because that degree of relatedness does show up. You also, if you think of it just in terms of a particular, let's say, pair bond, if there's less promiscuity, then you would imagine, let's say, males helping more if those offspring within that clutch of eggs, let's say, are more likely to be his. So you're going to see a lot more cooperation with monogamy as opposed to promiscuity, because of the increased relatedness between individuals, and then also the increased certainty of paternity, and in some cases maternity when you're talking about birds, of those offspring. So you're hitting it on sort of two separate fronts there. And I think that also answers that second question. You've got more promiscuity here in the independent breeders, less cooperation. In the more monogamous species, so as promiscuity goes down, monogamy goes up, and they're more cooperative for the reasons that we just stated a minute ago. This question is asking a little bit about the prisoner's dilemma and why reciprocity doesn't evolve very often. So first off, it says, can you explain how the prisoner's dilemma works and what defectors are in this context? So basically, the idea is, imagine putting two people in two different rooms. If they cooperate, so they call it prisoner's dilemma because it's basically you're cross-examining a suspect. If the two people that you're questioning, if they cooperate with each other, they both get a pretty high payout. If they cooperate, they're going to get, each one of them will get 1 year in prison. If one cooperates and the other defects, the defector gets 0 years, because basically he's pointing the finger at the cooperator. The cooperator isn't defending themselves. They're not pointing a finger back, right? So they're just taking all of that hit on them. So in this case, the defector gets 0 years. Okay, and in that case, if this one that was now cooperator, so the cooperator, if the other person defects, gets 10 years. So one cooperates, one defects. The defector gets 0, the cooperator gets 10, right? They both cooperate, they each get 1. They both defect, so they both essentially try to throw the other one on the bus, they each get 5. So you can see there's sort of this payoff asymmetry here. And in this case, what would happen is, as long as you're always going to get sort of this highest payoff right here, so think of it, you get 0 years. So being the defector right here, this is the highest payoff. And then both cooperate, so you're seeing over here the greater than signs. So this is the best payoff because you get 0 years. This is the second best because you only get 1 year. This is the third best because you get 5 years. This is the fourth or the worst because you each get 10 years. Okay, so what this shows is that if you are only going to play basically one time, then essentially the best strategy to do is to always defect. It basically says that reciprocity, this cooperate is not going to evolve. The strategy that typically is going to evolve when you're only doing it one time is the strategy where you defect. Okay, because more often than not, the other one cooperates, or they might cooperate, and you only get 0 years. But the fact that this other strategy has a higher payoff than the two cooperating essentially says that we're not going to see reciprocity evolving that much. Now, what we also see is that if you have repeated interactions, so now if these individuals are going to continue to interact with one another, so they have to cooperate, let's say on a daily basis, or not cooperate on a daily basis, that changes things quite a bit. So you can see a little bit more cooperation paying off in repeated interactions. But in a single interaction, very often the selfish behavior, defect, take care of yourself, throw the other guy under the bus, that's going to be the one that evolves. So the defector is the one that's basically behaving selfishly and not cooperating. Now, when we're looking at this from animal behavior, and we're looking at it from an evolutionary perspective, each one of these is a strategy. So think of it as there's a gene in the population, or an allele in the population for being a defector, and there's an allele in the population for being a cooperator. The advantage of a particular allele is going to depend on what other alleles in the population are doing. So if you are a cooperator in a population of a whole bunch of cooperators, you actually might do very, very well, right? But if you are a cooperator in a whole population of selfish individuals, you're going to do really horrible, because this is going to be over here in red. You're going to be cooperating, they're going to be defecting, and you're the one that's paying all the cost. So it's going to depend what other individuals are doing. But look at it here too. If you have a population of mostly cooperators and you're a defector, you do even better. And that's the whole premise of the selfish gene theory, is that even in a population of individuals that are mostly cooperating, if a defector gene arises, that gene can easily flood that population because it's going to do a little bit better. Now, if for some reason it didn't do better, then of course we'd have a different payoff matrix. But in this particular case, this is what our matrix looks like. This question is asking about the ground squirrels and the trilling, which is seemingly altruistic, because again down here, trillers actually get caught 8% of the time. So if you just keep your mouth closed and you don't make a sign, you get caught 4% of the time. But if you make that sound, that alarm call, you get caught 8% of the time. So that's why it's saying that this must be altruistic, because you do better if you did not make that sound. Whereas up here, whistlers, those that made the sound, actually only got caught 2% of the time. Those that did not make a sound, the ones that were just quiet, got caught 28% of the time. So now whistling is not altruistic, it's actually selfish, because if you whistle, you actually increase your fitness. Down here, if you trill, you decrease your fitness. So that's why we're saying that one tends to be more selfish, the whistling, and the other tends to be more altruistic, the trilling. Why that is a little bit hard to explain just from the data that we see here, but it may be, for instance, that predators can kind of cue in to the whistlers. It may be that the whistle maybe travels a longer distance, the predator hears it, and then the predator kind of knows that individual that just made that sound already sees them, and it's going to be harder for them to catch. So it's hard to know unless we know what the predator is doing in a response to that. But just from the data here, it shows that one of these is actually increasing their fitness, which is the whistle, and the other is decreasing their fitness, which is the trill.